Hi friends, let us understand how do we construct a triangle given the lengths of its medians. This is a really challenging problem because we are given lengths of the medians. We are not given anything about the lengths of the sides. Right, given lengths of sides, it is very easy to construct the triangle. But if we are given medians, how do we do this? Right, for this problem, we need to understand the proof that the medians are concurrent. That means they meet at a point which is called centroid, and this point actually divides the medians in the ratio of 2 is to 1. We have already proved this in one of our earlier sessions. Please go through that once. We will use a similar methodology here also. Okay, let's get to the solution. Let's say ABC is a triangle, right? ABC is the triangle and O is the centroid. Earlier we proved O is the centroid. How do we prove O is the, or we have already proved that this point O where two of the lines meet, two of the medians meet, that becomes centroid. We have already proved that the third median or the line joining A to O is actually a median to the third side. We have already proved this. Please go through the other video for that. Now, this O is the centroid, right? BO is to OY is equal to 2 is to 1, right? Now, to solve this problem, when given lengths of medians, we use this structure called parallelogram. This parallelogram, BOKC is a parallelogram, right? How do you know it is a parallelogram? Let us just revise the proof that we had done earlier. Right. By and ZC. These two are medians. O is the point at which they are meeting. Right. Let's connect A and O and extend this. And extend this. Right. Y is the midpoint of AC. Because BY is median. Y is the midpoint of AC. AC. Right. Let's draw a line KC. Let's draw a line parallel to BY going through C. Let's draw this line first. Okay, this line BY and KC are parallel. Right. And let this line AO, whatever, let it be extended until it meets this line, which is parallel to BY going through C at K. Right. Now this point OY is parallel to AC. Right. And Y is the midpoint of AC. What does that mean? Line which is parallel to the base of a triangle. In the triangle AKC, OY is parallel to KC, and one of the points is actually midpoint. Y is midpoint. That means O actually should be the midpoint of AK also. Right. O is the midpoint of AK. Right. Now, in this triangle ABK, O is midpoint of AK and Z is midpoint of AB. Because Z is again a median. Right. What does that mean? ZO, which is joining midpoints of two sides of the triangle ABK, should actually be parallel to BK. Right. So ZO is parallel to BK. That means ZC is parallel to BK. Right. And BY is parallel to KC. Right. If you see, there are two lines here. BY and KC, these two are parallel. BY and KC are parallel. Similarly, BK and ZC, these are also parallel. So what does it mean? The lines between set of two and two parallel lines is a parallelogram, right? What does that mean? BOKC is a parallelogram. Is a parallelogram. What does that mean? BX equal to XC and OX equal to XK because the diagonals bisect each other. So necessarily what does this mean? And this part OX equal to XK and OK is actually equal to OA. How do we know? Because this point we have already decided that this is the midpoint of AK, right? This is parallel to KC, and this is one midpoint. So obviously this is another midpoint. So AO equal to OK, right? AO equal to OK, and we have just decided that OX equal to KX because BOKC is a parallelogram, so this is equal to this, and BX equal to XC, BX equal to XC. So that means x is the midpoint of BC. That means AX is a median, right? We have already proved AX is a median, and this is equal to this. Let's say this is length, this is length, this is equal to this, and this AO is actually equal to OK. That means this is actually 2L. So AO is to OX is equal to 2L is to L, which is equal to 2 is to 1. So this is the proof. Quickly summarize that what we have done to prove that the medians are constant. At the same time, the median divides in the ratio 2 is to 1. Now for this problem, let us use this parallelogram. There is a parallelogram, right? Let's use the same parallelogram. So given lengths of three medians, let us first take one median. Let us call it, let's say the medians are x, y, z. X, y, z. Let us take this median, the first median only. Let us assume this is starting from A, and let us draw this. This length is x, and divide this in the ratio 2x by 3 and x by 3 and x by 3. Right? AO is 2x by 3, OX is x by 3. So far, so good. Right? We have drawn this. But we don't know where is from which point we have to draw the median, other two medians. Don't worry. Right? Let's do one thing. From this point, let's just extend this line further and call it another x by 3. Right? This is what we are doing here. This part, because this part is equal to this part. Right? Let us just extend. So we have arrived at this point called k. Right? Now from k, let us take this length. This, let's say this is x. This median is y. This median is z. Right. From k, let us take 2 by 3z, which is equal to this. Right. 2 by 3z is this. Because z by 3 is this. Right. 2 by 3z is this, which is also equal to this. Right. From x, let's take 2 by 3z and put an arc. Right. Similarly, this is O. Right. From O, this part becomes, this part becomes 2 by 3, 2 by 3 y. Right. This part is BO is 2 by 3 y, and this is y by 3. OY is y by 3. Similarly, 2z by 3 is OC, and z by 3 is ZY. Right. So BO is actually 2 by 3 y. So from O, let's draw one line which is equal to one arc which is equal to 2 by 3 y. So from x it is 2 by 3 z. This is 2 by 3 z because this is a parallelogram, and this is 2 by 3 z. So this also is 2 by 3 z. Similarly, this is 2 by 3 y. This is also 2 by 3 y. So from x 2 by 3 z we draw, right, and from y, from O 2 by 3 y we draw, right, and so we are arrived at what is B. Now B and this part we can easily join it. This part is x, and let's continue this further. Right, from K again 2 by 3 y, let's take one arc and let this cut it at 2 by 3 y. Right, this point becomes C. This is C. So this is our triangle. ABC is our triangle. So what have we used here? We have used this parallelogram construction, which we used for the derivation of concurrency of medians as well as medians cutting in 2 is to 3, 2 is to 1 ratio. Centroid cutting 2 is to 1 ratio. We use the same philosophy here, right? There is a parallelogram here. So what does it mean from this point K, right? From this point K, which is actually AX extended or AO extended, which is actually one third of one of the medians, right? The total is 3L and this is L. So kx, we are taking one of the medians and drawing it and then extending it by one third more. Right? We are drawing it x and then extend it by x by 3 more. At the same time, we are deciding what is the center. Right. From the centroid, from this point K, from this point K, this B will be 2 by 3z. The distance to B is 2 by 3z, and from centroid it will be 2 by 3y. Right. That's how we have arrived at B. Similarly, the C also we can arrive in both ways. Either we can connect B, X and extend, or from K again it is 2 by 3 by, and from O it is 2 by 3 Z. We can do either way. Right? From O we can decide 2 by 3 Z, and from K you can decide 2 by 3 Y and arrive at C. Right? That's how we arrive at A, B, C. When we are given the lengths of medians also, we can actually draw the triangle. This is really important. Hope you understood this. If you haven't understood, please message. I will take this again. First, understand the proof of concurrency of medians and centroid dividing medians in the ratio 2:2. Once we understand the proof, this becomes a cakewalk. Right? Hope you guys like this. Thank you guys. This is little advanced. This you don't generally get this question in regular school, but this is little advanced. But nevertheless, it is very important proof, very delighting. Thank you, guys.